Okay, the power rule. Okay, so like I said, this is probably not going to take us very long because we've already seen the power rule through patterns using the difference quotient. But it says finding the derivative from first principles can be tedious. The following table shows the results of finding the derivative of several different polynomial functions. Okay, now this is another way of writing the notation. What we've seen so far is using that little prime notation, like there's a table there. If we have function f, f prime would represent the derivative, but you can also use this notation dy dx, a change in y over the change in x, okay, the derivative of y in terms of x. So you'll notice x to the fourth would be 4x cubed. X cubed 3x squared, x squared 2x, and so on. And the negatives are going to follow the same pattern. So what's happening here is just like we discussed before starting, the power, whatever it may be, you pull that to the front and multiply it by the coefficient, but then you subtract 1 from the power at the same time. Okay, so that's what it has right here. If we have x to the n, then this would be referred to as the derivative. Okay, and this is the first derivative. Now, if you were to apply that for a second time, then we'd call that a second derivative. Okay. Well, let's just get right to it and see what we think. Oh, did someone knock? Hey. Okay. So it says use the power rule to find the first derivative and the second derivative for the following functions. Okay, so my function is x to the sixth. Okay, so using the power rule, I'm going to pull the 6 to the front. The only coefficient is 1. So 6 times 1 remains 6. But then I subtract 1 from the power. There you go. So the first derivative should just be 6x to the fifth. Okay. If I want the second derivative, I'm just going to apply the same strategy once more. Okay, Graceland, what would the second derivative be? One more time, man. Oh, now you're on B. Okay, so she went ahead a little bit. The first derivative of 12x cubed, 3 times 12 is 36. Subtract 1. Yes, that's absolutely right. But I'm looking for the second derivative of A. So the first derivative was 6x to the fifth. So what would the second derivative of x to the sixth be? Okay, Evelyn, can you help her out? There you go. 5 times the coefficient in front, that would be 30. Subtract 1 from the power. 30x to the fourth. Yes. The second derivative is acceleration. Typically in these word problems. So I think really the only thing you guys are most likely to be doing, all I've ever seen have been those word problems that incorporate this usually deal with speed. I don't believe I've ever seen one deal with acceleration. But if it should happen to come up, now we know. Okay. All right, is everybody okay? Anybody have any questions how we're finding that? Okay. Hillary, help me out with this next one. What is the second derivative for 12x cubed? That's it. 2 times 36, 72. Subtract 1 from the power, and there we go. That's it. Okay. All right. Let's try x squared over 7. How about Emily? Can you help me out with that? Now, if it helps, maybe rewrite it. X squared divided by 7, that's the same as 1/7 x squared. You can kind of separate that numerator from the fraction as long as it's still joined by multiplication. Okay, that's right. So I'm going to go ahead and multiply the 2 times the coefficient. So that's going to be 2/7 x because the 2 minus 1. All right. And now I want the second derivative. Sierra, can you help me out with that one? So what's the derivative of 2/7 x? Oh, it's not the same. Just 2/7. There we go. Because right now your power is 1. So I'm going to multiply 1 times the coefficient. So there's 2/7. But then I still have to subtract 1 from the power. So that would leave me x to the 0. But what's anything to the 0 power? 1. So there we go. Okay. And just to bring up the idea again, what's the derivative of a numerical value? Like what would the derivative of 2/7 be? 0. The derivative of a value is just 0. Okay. And let's try this one. 3x to the negative 3, so you'll most likely see these as, 3 over x cubed, just making a negative power. Okay. So let's see, who haven't I talked to yet? Zoe, what would be the first derivative for 3x to the negative 3? Negative 9x to the negative what? Perfect. Again, negative 3 times... I just lost my train of thought. Negative 3 times 3, there's your negative 9. And then when you subtract 1 from the power, okay, you get negative 4. Negative 3 minus 1. Remember, with the negatives, it's a little different because the larger it looks, the smaller it actually is. Okay, very good. And let's see here. Who can finish it off? Camille, what would the second derivative for 3x to the negative 3 look like? Oh, 36 x to the negative 5. There you go. That's exactly right. Anybody having a hard time? Anybody confused? Okay. Well, let's take a look at a couple rules we got here. Derivative of a sum or a difference. So if I've got y is equal to some function f plus some function g, then the derivative would be the derivative of f plus the derivative of g. Same thing for a difference. Okay. And these rules are what allow us to easily take the derivative of these. It's basically, because of the addition and subtraction, I can go ahead and just take the derivative of each of these terms individually. So for example, if f is equal to 2x cubed plus 5x minus 9, okay, f prime, okay, which could also be written the derivative of y in terms of x. Well, what's the derivative of 2x cubed? That would be 6x squared. 3 times 2, and then we subtract 1, plus, and then we just take the derivative of that. 5x would become 5, and what's the derivative of a constant? 0. So it's just 6x squared plus 5. In fact, would anybody like me to run through the difference quotient very quickly, take the limit as h approaches 0, and show you that we're going to get the exact same thing? Anybody want to see that to make a connection with what we had before? No? Okay. Then here's a question. How would I take care of b? How would I do that one? Now, there is a differentiation rule. That's another way of describing taking a derivative for a quotient, but luckily we don't have to look at it. You can. Now, what does each numerator have in common? There you go. Because it's one big fraction, see, they're all over x, right? So for f of x, I could say 5x squared over x plus 4x over x minus 3x cubed over x. It's just another one of those rules that's reversible in mathematics, and it makes it a lot easier for us to work with. Okay, so now I can simplify each of them individually. So this would be 5x plus what? Plus 4 minus 3x squared. Okay. And then now it's just a matter of taking the derivative individually like we were doing just a moment ago. Okay. Alejandra, what's the derivative of 5x? 5. Okay. John, what's the derivative of 4? 0. Okay. The derivative of a constant is just 0. Now see here, the reason this works is because I have 1 times the 5 and then I subtract 1. Okay. So I'm not going to put anything there for the 0. And Caitlin, what about the negative 3x squared? Close. It is negative. Now we're going to take the power and we multiply it by the coefficient. So negative 6x. And then from that one, there we go. We subtract 1 from whatever my power was. There we go. Okay. So that would be the derivative. Okay. Questions? Okay. Well, let's go ahead and see what else we got. Okay, find the gradient function for f of x equals 9x minus x cubed using the power rule, and hence find the gradient of the tangent to the function when x equals 2. So this is where we start going a little further. Once we have the derivative, we start finding the slope of a tangent line at a particular location, but then we can also get a little more involved with these. Okay, so if f equals 9x minus x cubed, who haven't I talked to today? How about Caroline? What would the derivative of 9x minus x cubed be using the power rule? Okay, she says 9 minus 3x squared. You guys agree? Perfect. And then now find the gradient of the tangent when x equals 2. So what it's asking me is, now that I have the derivative, we're plugging 2 in there. So this would be 9 minus 3 times 2 squared. So let's see, 2 squared is 4 times 3, 12. 9 minus 12? Negative 3. So the slope at that location should be a negative 3. Is anybody having a hard time? You never knew calculus could be so much fun, huh? Now, there's way more involved in this, but I mean, this is really the basic idea of a derivative. Okay. Let's try the next one. Find f prime of 3, given that f of x equals x cubed minus 2x squared plus 10. Okay. Now, do you want to work this one together as well, or would you like to try one on your own?
Why don't we do it on our own?
Try it on our own. Okay, let's do that. Give you a minute or so. All right, who thinks they know the final answer, the gradient? Samir, what'd you get? 15. That's exactly right. Okay. Let's go to Marissa. What would the derivative of the trinomial be? 3x squared minus 4x. Perfect. Okay. The derivative of 10 is 0. And find f prime of 3. So 3 times 3 squared minus 4 times 3. Okay. So we're looking at 27 minus 12. We got that 15. How many people got that right? Good. Good, good, good. Okay. Now, they can ask these same questions in different ways. This next one says, find the gradient of the curve y equals 3x squared plus 4x minus 1 at the point 1, 6. The only difference here is it's giving you the actual location of where they're wanting the tangent line. They're still just telling you, okay, find the slope when x equals 1. Okay, because that's the value of x located in that coordinate. Does that make sense? Okay. So what would the derivative be?
6x.
I heard 6x plus 4. Perfect. All right, now just go ahead and plug in 1. 6 times 1 plus 4, I'm looking at 10. Would anybody like me to go ahead and graph this real fast and show you, at that point we should have a pretty steep line. It should be 10? No? Okay. Then, I believe we're almost done. I think these are the last few problems. Man, we are moving through this calculus stuff. We feeling good about it? Good. Okay. All right. Determine the coordinates on the curve. Okay, so when we have x going to x cubed minus x plus 2, where the gradient is 11. So this one's different. We are working backwards. What's it giving you this time? This time it's giving you the slope. We want to go ahead and work backwards. I want to know what are the coordinates. What are the locations where this function would have a tangent line whose slope is 11? Okay, now, do you want to try this one on your own? You want to try it on your own? Okay. Does anybody need help getting started? Okay, so a few folks. So let's do this. How would you, let's say on those previous problems, let's say you wanted to go ahead and find the slope at a particular location. Well, what's the first thing we've been doing? We always find the derivative first. So let's start there. Okay, so what would the derivative be? So I heard 3x squared minus 1. Okay, because the 2 derivative of a constant is 0. So that's my derivative, right? So let's say this is f of x. Oh, f prime of x, excuse me. And then normally they say, okay, at a certain location, find the slope of that tangent line. Well, here we are given the slope. We want to know where that slope happens. So what am I going to do with the derivative and the slope? There you go, because I already know what it should equal. I just need to find where this happens. See, because if you're working backwards, once you know the value of x, that allows you to find what? The y value. There you go. And maybe it's just one location. Maybe it could end up being 2. Very possible. Okay. So does that help? Okay. So I'll give you a little bit of time to take a look at that. So once you get that, if you're feeling, ambitious, go ahead and try this last problem here. We're talking about the position of a car moving along a straight road given by s of t equals 3t squared plus 5t meters, where t is the time in seconds. Find the derivative of s in terms of t using the power rule, and then determine the derivative when the time is equal to 5 seconds. Yes.
Once we find x, do we plug it into the derivative? Or
Yes. No, you don't plug it in the derivative. You plug it back into the original function. Yes. That's a good question. Not the derivative, the original function. Excuse me. Okay. And since we are going to be finishing up the lesson today, I'll go ahead and give this to you guys as well. This would be, this would be the next assignment over the power rule. I was thinking Friday. Now we have a reason to get up in the morning. Go sleep in. I got calculus to do. You got what? Oh, you have history reading? Yes. History's fun, but math is more fun. Oh, I'm sorry. Yeah, empty seat there. My bad. There we go. Okay. All right. So let's say the power rule assignment will be due on Friday. And today is Wednesday. Excuse me. Okay. Is everybody about ready for this one? Okay. How many coordinates did we end up with? I actually ended up with 2. There you go. Okay, so let's go ahead and solve it. I'm going to add the 1 over, so 3x squared would equal 12. Divide by 3, so x squared is equal to 4. So take the square root, and remember we're taking an even root, so we would want to put plus minus in front of it. So x would equal plus or minus 2. So I know there are 2 locations where I should have a tangent line that has a slope of positive 11. The first is 2, and the second one is negative 2. And this is what Alejandra was asking about. Do we go ahead and plug that back into the original function or the derivative? The original function. If I plug these values into the derivative, all it's going to provide me is what? The slope at those locations. One of which being, we already found. Does that make sense? Okay. So let's plug it back in here. So if I plug 2 in, so 2 cubed minus 2 plus 2, well, that's easy enough. We get what? 8. And if I plug in a negative 2, so negative 2 cubed. Now we're subtracting a negative, so that's a plus 2 plus 2. So that's going to be negative 8 plus 4. Negative 4. So 2 locations where that happens. How many people got both of them? Okay. How many people did it right? We just forgot the plus minus. You still got that 1. That's good. That's good. That's real good. Okay. Last problem. Okay, so we already read it. So let's go ahead and find the derivative using the power rule. That'll take care of A pretty easy. Who have I not talked to today? How about Araya? What's the derivative, or first principle, okay, of 3t squared plus 5t? 6t plus 5. Perfect. Okay. Now it says determine the derivative when the time is equal to 5 seconds. Okay. So if t is equal to 5, then if we input it in here, we're going to have 6 times 5 plus 5, which is going to give me 35. Now what does this represent? Well, it's true if I were to look at it graphically, but in context of the problem. Remember, the first derivative is speed. There we go. So we know that at 5 seconds, the car is actually traveling 35, what are we talking about, meters per second? Okay, meters per second. That's actually going pretty quick, yeah. How are we doing on the power rule? Anybody have any problems, any questions? All right. Okay, well, I'm going to go ahead and let you guys start looking at that. Remember, tomorrow when we come in, we have that exit ticket. I don't think it's going to take you very long. I don't expect it to. Then we'll talk about the homework on Friday. We'll take our quiz, and we'll see if we're able to start our final lesson of the year before we get to reviewing. Okay.